Hey guys, welcome back to Sleepy Science Stories, where bedtime isn't just a suggestion, it's a scientifically recommended lifestyle, especially if you've spent the day fighting Wi-Fi, existential dread, or group texts about who's bringing the potato salad to next week's barbecue. Tonight, we're not drifting through memories or counting sheep, we're counting clouds, molecules, and mildly concerning weather phenomena. That's right. You're about to float through 100 of the most peculiar, mind-bending, and oddly comforting facts about Earth's atmosphere. Yes, the atmosphere, that invisible safety net standing between you and instant cosmic exfoliation, the world's softest blanket, only occasionally trying to drop a hailstorm on your car or give you a truly regrettable sunburn. It's a place where the air you just inhaled was probably inside a dinosaur, a medieval knight, and at least one confused pigeon. The atmosphere is less like a five-star hotel and more like your uncle's living room, sometimes cozy, sometimes stuffy, and occasionally home to a suspicious number of science experiments gone wrong. Don't forget to like, subscribe, and leave a comment if you actually enjoy this kind of thing. No pressure. Just a gentle suggestion, floating along with the next gentle breeze. Your engagement keeps the algorithm gods happy and helps more sleepy souls find their way to this channel, one deep breath at a time. So, let your thoughts start to float. Notice the quiet around you, the hum of your fan, maybe the distant sound of traffic, or the soft creak of your house settling. Ready? Let's take a deep breath together. Inhale, exhale. Tonight, you're lighter than air. Let's begin. You wake up, groggy and weightless, floating gently in what feels like a warm, invisible duvet. It's not a weighted blanket, it's Earth's own atmosphere, a cocoon of gases stacked up higher than your neighbor's Wi-Fi bill. If you've ever wondered why you aren't instantly freeze-dried like coffee grounds, thank this gentle layer. Tonight, we're breathing in its mysteries, molecule by molecule. Let's start by asking a sleepy but important question. What exactly are you floating in? If you've ever tried to hold a handful of air, you've probably ended up looking mildly ridiculous, standing in your kitchen, grasping at nothing while your cat judges you from the counter. But the atmosphere is anything but nothing. It's a blend of invisible ingredients, carefully measured over billions of years. About 78% nitrogen, the introvert of gases, always present but rarely making a scene, 21% oxygen, the one you'll notice if it's missing, and the rest, a sprinkle of argon, a dash of carbon dioxide, and a trace cocktail of water vapor, neon, helium, and more. Take a moment and picture this. You're floating 10 miles above the ground, looking down at the curve of the Earth, wrapped in this transparent shawl. It's thinner than you'd think if the planet were an apple. The atmosphere would be the skin, and a pretty fragile one at that. And yet, it's the only thing standing between you and a universe so empty and cold it would make your old office fridge seem cozy. Ever wondered why, in every science fiction movie, stepping out without a helmet ends badly? It's not just for dramatic effect. Without our atmosphere, your blood would boil, your tears would vaporize, and you'd get an instant full-body sunburn from all the radiation the air usually blocks. Not the best look, unless you're really into the crispy astronaut aesthetic. Let's talk about the structure for a moment. The atmosphere isn't just a shapeless fog, it's layered, stacked neatly by temperature and pressure, like a cosmic 7-layer dip. Closest to the ground is the troposphere, where you do all your living and breathing and questionable karaoke. Above that is the stratosphere, home to high-flying jets, and the heroic ozone layer, protecting you from the sun's more questionable vibes. Then the mesosphere, thermosphere, and finally the exosphere, where air grows so thin, you might as well call it not air. Each layer comes with its own rules, moods, and favorite weather disasters. Now, take a slow breath and notice the air filling your lungs. The pressure you feel is the weight of all the air stacked above you, about 14 pounds per square inch, pressing down on your skin every moment of your life. But don't worry, You're built for it. In fact, if you ever feel like life is too much pressure, just remember you're already carrying the weight of the entire sky and still managing to make coffee every morning. But it's not just about what the atmosphere is made of, it's about what it does. It keeps temperatures steady, moving heat from place to place like the world's least reliable space heater. It lets plants and animals trade oxygen and carbon dioxide in a complicated barter system that would make any economist dizzy. It carries weather, whispers sound, and even allows for the occasional rainbow or thunderstorm, just to keep things interesting. Finally, if you're still awake, imagine trying to fall asleep without this atmospheric blanket. No gentle breeze, no birdsong, not even the muffled honk of distant traffic. Just cold, silent emptiness, and a sneaking suspicion you forgot to put on sunscreen forever. So tonight, as you settle deeper into bed, let the invisible blanket of the atmosphere tuck you in. Every breath, every sigh, is proof that you're wrapped in one of the universe's rarest comforts. A planet with just the right mix of gases, pressure, and warmth to keep you dreaming, breathing, and gently floating into sleep. Take a deep breath. Now thank the ancient slime-green cyanobacteria that made it possible. Billions of years ago, Earth's air was less sparse, more hazmat suit required. The oxygen in your lungs right now, that's their passive-aggressive housewarming gift to the planet. Let's start with a simple question. What would happen if you tried to breathe Earth's air 3 billion years ago? Spoiler alert, it would be like sticking your face into a bag of rotten eggs and cleaning supplies. Early Earth's atmosphere was a wild party of methane, ammonia, carbon dioxide, and basically everything you'd find in a particularly adventurous household cleaning caddy. Oxygen? Nowhere to be found. If you'd taken a whiff back then, you'd have regretted it immediately, assuming you had lungs at all. So how did we get from there to the lovely, breathable air you're lounging in tonight? The answer is as glamorous as it sounds. Pond scum. Enter the cyanobacteria, tiny, ancient microbes that made their home in shallow seas, bubbling away and minding their own business. But these weren't just any bacteria, they were innovators. They figured out photosynthesis before it was cool, using sunlight to turn carbon dioxide and water into sugar, and crucially, releasing oxygen as a byproduct. Now, you might think, well, thanks pond scum, but how much difference can a few billion single-celled organisms really make? The answer, more than your HOA president at a neighborhood meeting. For millions of years, these cyanobacteria pumped oxygen into the oceans, saturating the water until it finally started spilling over into the air. This was the planet's first major atmospheric makeover. Scientists call it the Great Oxidation Event, but you could also call it the world's slowest but most effective air freshener. In fact 5. Of course, not everyone was thrilled. For most of the life forms at the time, oxygen was toxic, like inviting everyone to a party and then filling the punch bowl with bleach. There was a mass extinction, a planetary drama, and a biological reset button. But for those who could handle it, oxygen was a game changer. It allowed for bigger, more complex life forms, eventually leading, after several billion plot twists, to you lying here, taking slow, sleepy breaths and listening to science stories. Let's take a closer look at cyanobacteria. Imagine an ancient tidal pool, warm and sluggish, with sunlight slanting through greenish water. Slimy mats of cyanobacteria spread across rocks, burping out bubbles of oxygen that drift lazily upward. Over eons, these humble organisms became the greatest terraformers in history. If you think your houseplants do a decent job purifying the air, cyanobacteria laugh in 3 billion-year-old well, whatever passes for laughter in a microbe. Even today, their descendants are still around. The next time you see a pond with a suspicious green scum, you're looking at the planet's original breath givers. And when you gaze up at the sky, every cloud, every breeze, every lazy afternoon spent napping on the grass, all of it traces back to a single evolutionary gamble. the decision of some ancient bacteria to try photosynthesis. It's the ultimate example of passive-aggressive generosity. Here, have some oxygen. Oh, you weren't ready for that? Oops. It's easy to take for granted that every inhale delivers life-giving oxygen straight to your cells. But tonight, as you drift off, remember the strange, accidental miracle that made it possible. Billions of years ago, pond scum did something utterly weird and quietly heroic. They didn't know they were changing the world, they were just doing their thing, turning sunlight into sugar and making bubbles. So as you settle under your own invisible blanket of oxygen-rich air, maybe send a thank you to the ancient slime that gave you the gift of breath. Every sigh, every yawn, every sleepy moment is a reminder. Sometimes the most important changes start small, weird, and a little bit slimy. Imagine the sky as a simmering pot of soup. Clouds are the croutons, humidity is the broth, and every now and then, someone probably named Cumulus dumps a whole bucket of ice cubes in. Welcome to the atmospheric kitchen, where every recipe comes with a free side of rain. Let's begin tonight's recipe by examining what's actually cooking above your head. You're lying in bed, eyes closed, and somewhere up there, water vapor is swirling, mixing, and condensing like a sleep-deprived chef with a bottomless pantry. The air, surprisingly, is always a little damp, even in the driest desert. There's invisible steam in the sky. That's humidity, the world's quietest, most persistent ingredient. Now, humidity isn't just a word your weather app throws around to justify your frizzy hair. It's the amount of water vapor, the gas form of water suspended in the air at any given time. If you could somehow wring out the entire atmosphere like a giant sponge, you'd get about 12,900 cubic kilometers of water. That's enough to fill about 5 billion Olympic-sized swimming pools. Or, more realistically, ruin your picnic every single weekend for the next 1,000 years. But soup without garnish is just, well, hot water. Enter clouds. Those fluffy, floating islands that drift by with all the purpose of a retired golden retriever. Clouds form when humid air rises and cools, causing the water vapor to condense into tiny droplets or ice crystals. It's as if the kitchen gets cold enough for the steam to turn into actual soup chunks. These chunks float together, growing bigger, fluffier, and more dramatic until the Weather Channel gives them a name. And speaking of names, not all clouds are created equal. Meet Cumulus, the puffy, friendly type who looks like he's auditioning to be the Michelin Man's sidekick. Then there's Stratus, the flat, grey, moody cousin who insists on blocking the sun right before your big outdoor plans. And don't forget Cirrus, the wispy high flyer, always up at the edge of space, dropping ice crystals like glitter at a child's birthday party. Sometimes, the sky chef decides to get creative and layer the clouds, stacking them into towering columns or swirling them into wild, spiraling shapes. If you've ever stared up at a sky full of strange patterns and wondered if someone spilled milk across the heavens, you're not wrong. Those are atmospheric convection currents, mixing the ingredients, stirring the sky. But what happens when the pot starts boiling over? That's when rain, snow, or hail tumble out. Think of rain as the soup ladle, delivering just the right amount of liquid to wherever you forgot your umbrella. Each raindrop starts as a tiny particle, a speck of dust, pollen, or sometimes bacteria, surrounded by a thin layer of condensed water vapor. When the drop gets big and heavy enough, gravity steps in, and down it falls, completing its journey from invisible vapor to soggy socks. Ever wondered why rain can feel different, sometimes misty, sometimes pouring, sometimes practically sideways? That's all about how the soup is stirred. Wind, temperature, and the ever-fickle chef called chaos all play a role, ensuring you never get exactly the same recipe twice. Thunderstorms are the pressure cookers of the sky, brewing up drama with every flash and rumble. Tonight, as you drift off, picture yourself as a tiny ingredient in this planetary stew. You're part of the cycle. Every breath you exhale adds more humidity. Every sigh becomes a drop in the vast, simmering broth. And as the clouds gather and swirl, you realize the sky isn't just above you, it's around you, beneath you, inside you, too. So next time you look up and see a patchwork of clouds, or feel the dampness in the air, remember, you're living inside the world's largest, strangest, most unpredictable pot of soup, and you're always just one lazy cloud away from a midnight snack of rain. Suddenly, you're soaring up a mountain, ears popping, snacks inexplicably tasting blander, and your chip bag threatening to explode like it's auditioning for a viral TikTok. Atmospheric pressure isn't just a fun physics term. It's the reason your body doesn't inflate like a party balloon. Let's settle in and picture it. You're cruising in an airplane, 0 feet above the ground, encased in a giant metal tube, eating peanuts out of a crinkly bag that's been puffed up like a nervous pufferfish. All around you, the air is thin, so thin, in fact, that if the windows were to magically pop open, don't worry, they won't, you'd get an express ticket to the Why Oxygen Masks Exist Club. Your body, built for cozy sea-level comfort, is suddenly a guest at the atmosphere's weirdest party, the low-pressure zone. But what exactly is atmospheric pressure? Imagine the entire column of air above your head, stacked up to the edge of space molecules upon molecules, all pushing down on you with the gentle insistence of an overzealous blanket. At sea level, that pressure is about 14.7 pounds per square inch, or roughly the weight of a large house cat standing on every inch of your skin. Cozy, right? You're basically being hugged by the sky, all day, every day. Now, start climbing. As you go higher up a mountain, into a plane, or even onto a really ambitious ladder, the amount of air above you shrinks. The higher you get, the less air is left to press down. This is why mountaintop cookies puff up weirdly in the oven, and why your water boils at a lower temperature when you're camping above the tree line. Lower pressure means there's less force squeezing things together. Water molecules can escape into the air more easily, so your soup boils away in a hurry. Unfortunately, so does the air inside every bag of chips you bought for the hike. And then there's you, your ears, your lungs, your taste buds, all along for the ride. Ever noticed your ears popping when you ascend quickly? That's your body frantically trying to equalize the pressure inside and out. If it didn't, your eardrums would feel like someone's testing a new brand of internal fireworks. It's the same reason you yawn and swallow on airplanes or during elevator rides. Your head's own built-in pressure valve at work. At high altitudes, there's another quirk: your snacks just don't taste the same. That's not the airline's fault, well, not entirely. The dry, thin air actually numbs your sense of smell, which is responsible for much of what you taste. Suddenly, your favorite chips taste bland, and even your water seems to have lost its personality. Meanwhile, the bag is inflated to the point that opening it feels like diffusing a snack-based balloon animal. And here's a fun fact. If you could somehow survive outside the plane at 0 feet, you'd find yourself in a low-pressure situation so dramatic, your bodily fluids would literally start to boil at body temperature. No, not in a dramatic cartoonish explosion, more like a slow, science-y simmer. Not ideal for sleep, but certainly great for scaring yourself awake in the middle of the night. Back on the ground, the pressure quietly holds you together, keeps your blood from fizzing, and makes sure your lungs can deliver oxygen without turning every breath into an Olympic event. Every time you sigh, yawn, or pop your ears, you're balancing the forces that keep your organs, well, where they belong. So, as you drift off tonight, take a moment to appreciate the atmospheric pressure hugging you gently from all sides, keeping your world stable, your body intact, and your chip bags mostly under control. Without this invisible force, life would be a lot less crunchy, a lot more dangerous, and you'd have to explain to your neighbors why you floated past their window during their morning coffee. Breathe deep, settle in, and let the pressure hold you just the right amount, just the way you need it. Ever sniffed the air after a thunderstorm and thought, if only I could bottle this for my next Zoom meeting? That dreamy scent is petrichor, nature's own aromatherapy, brewed up by raindrops and soil bacteria. It's the only cologne guaranteed to remind you of skipping homework and splashing in puddles. Let's settle into that scent for a moment, the way it wafts in through your open window, mingling with the cool hush after rain, making the world feel softer and new. There's something almost magical about it. No artificial air freshener, no luxury candle, not even that suspiciously expensive bottle at the department store can quite capture the same comfort. Why is the smell of rain so universally nostalgic? And more importantly, what's really happening up there in the atmosphere when your nose says, "Ah, finally it rained, time to zoom in." Picture a single raindrop falling from a sullen, grey sky. It tumbles through the air, picking up bits of dust and pollen before landing on warm, thirsty earth. That's when the chemistry show starts. The ground, it turns out, is a little bit of a hoarder. Hidden in the soil and on rocks are tiny, fragrant molecules called geosmin, made by actinobacteria, microscopic soil dwellers who have been quietly creating the scent of fresh for millions of years. They're the real perfumers here, working 24/7 without a single influencer sponsorship. As the raindrop hits the surface, it bursts apart in a gentle explosion, sending little bubbles of air upward. These tiny bubbles act like elevators, whisking geosmin and other scent molecules up into the atmosphere and straight to your nose. Add to that a pinch of plant oils, which plants release during dry spells as their own form of self-care, and you've got a recipe for nature's finest eau de toilette, petrichor. But wait, there's more. Thunderstorms, those drama queens of the weather world, add another twist to the mix. When lightning splits the sky, it also splits apart nitrogen and oxygen molecules in the air, which then recombine to make ozone, a gas that brings a sharp, almost metallic freshness. That first, electric scent right before a downpour, that's ozone, letting you know a storm is on the way. It's like your own personal weather notification, but far more pleasant than any app alert. Now, here's a question for your next sleepy thought spiral. Why do our brains love this scent so much? The answer is quietly ancient. The smell of petrichor signals water a cue of survival, hardwired into mammals over eons. For early humans and animals, the scent of rain meant relief, new growth, maybe even a reason to celebrate. It's like your brain is running a legacy program from the Stone Age. Rain? Time to relax. Everything's going to be okay for a while. The next time you find yourself caught in a shower, notice how everything seems more vibrant. The colors look brighter, the air feels cooler, and even the world's most reluctant houseplants perk up. This isn't just nostalgia, it's a complex chemical symphony, tuned perfectly to comfort, calm, and even make you a little bit sleepy. If you're lucky enough to have memories of playing outside in the rain, mud squishing underfoot, water dripping from your hair, shoes forgotten somewhere in a puddle, petrichor is your shortcut back to that moment. A simple inhale, and you're 8 years old, immune to soggy socks and totally unconcerned with deadlines. So tonight, as you breathe in and drift towards sleep, imagine the gentle patter of rain against your window. The world is washed clean, the air is perfumed, and every molecule of petrichor is a quiet invitation to relax. Nature's cologne, no bottle required. Above your bed and above your neighbor's overgrown hedge, there are not one, not two, but 5 main layers of atmosphere, each with its own dress code and vibe. From the troposphere's moody weather to the thermosphere's cosmic tanning salon, let's take the express elevator upward. Picture yourself, tucked under your blanket, but instead of a ceiling, there's an invisible skyscraper rising above you, one with 5 stories, each stranger than the last. As you float upward, each layer welcomes you with its own peculiar personality, like moving through a stack of cosmic apartments, each with a different set of rules for guests. First stop, the troposphere. This is the ground floor, where all the action happens. It's where you live, where the clouds float, and where every awkward small talk about the weather originates. The troposphere stretches from the surface up to about 7 to 12 miles high. It's a little clingy, holding tight to most of the atmosphere's mass, keeping things cozy, damp, and a tad dramatic. All weather, rain, snow, thunderstorms, even that gust of wind that steals your hat happens here. The higher you go, the colder it gets, which is probably why clouds prefer to hang out low, where the temperature is less judgmental. Step into the elevator and press up. Ding. Welcome to the stratosphere, the atmosphere's VIP lounge. Here, from around 12 to 30 miles above the Earth, the air is dry, the winds are steady, and the temperature, oddly enough, starts rising as you climb. This is where commercial jets cruise to avoid turbulence, and where the famous ozone layer throws an ultraviolet blocking block party. The ozone acts like a cosmic bouncer, turning away the sun's most obnoxious guests, UV rays, keeping you from crisping up like a forgotten toaster pastry. One more level, the mesosphere. Not much happens here, unless you're a meteor. This layer, stretching from about 30 to 50 miles high, is the atmosphere's forgotten middle child. It's cold, colder than your ex's text replies. In fact, the mesosphere is the chilliest part of the atmosphere, often dropping to 130 degrees from 90 degrees. This is where meteors burn up in spectacular streaks, so you can thank the mesosphere for every wish you've ever made on a shooting star, and for stopping those rocks from landing on your car. Press up again, and you're in the thermosphere. Think cosmic tanning salon. Here, between 50 and 375 miles up, the temperature rises fast, thanks to the sun's intense energy. You could be baked by solar rays until the air molecules are zooming around at thousands of degrees, but plot twist, the air is so thin you wouldn't actually feel hot. This is home to the auroras, those shimmering northern and southern lights that look like the sky is finally learning to dance. Last stop, penthouse suite, the exosphere. Here, the air gets so thin, it's basically outer space. There's no clear boundary, just atoms and molecules escaping, like party guests sneaking away at dawn. Satellites orbit here, floating in the calm, watching over your GPS, your weather apps, and your late-night web searches for, "Why does my cat stare at me?" But wait, the elevator has no roof, the atmosphere just fades away, until the only thing left is the endless dark of space. Each layer has a purpose, holding in warmth, blocking dangerous rays, burning up space debris, and giving us weather, sunsets, and rainbows. The atmosphere is the world's weirdest, tallest, most essential layer cake, and every night, as you drift off, you're nestled safely in the frosting at the very bottom. So, as you snuggle deeper into your bed, remember, above you, a 5-layer wonder keeps you safe, cozy, and just the right amount of sunburn-free. Sweet dreams from all the stories stacked over your head. The next time you're cozy in bed, listening to a storm, remember you're hearing a full percussion section powered by electrical chaos. Lightning heats the air hotter than the surface of the sun, and thunder. That's the atmospheric equivalent of a mic drop. Let's rewind and drop you right into the heart of a summer storm, your blanket pulled up, window cracked open, the air tingling with anticipation. The sky outside is brooding, moody, electric. Then, with a flash that briefly turns your bedroom into a photography studio, lightning streaks across the sky. It's nature's brightest and most alarming strobe light, and for a split second, you could read a novel by the glow if you weren't too busy staring in awe, or trying to remember if you left your phone plugged in. What's really happening up there? Lightning starts as a silent, invisible drama. Deep in a cloud, ice crystals and water droplets bump and jostle each other, trading electrical charges like overcaffeinated stock traders at a very moist Wall Street. The top of the cloud loads up with positive charges, while the bottom hoards the negatives. As the electrical imbalance grows, the air itself can't take it anymore. It's like a cosmic static shock, except instead of shuffling across the carpet, you're rearranging 1 billion volts of electricity. When that charge finally finds a path, either to another cloud or all the way down to a hapless tree, or sometimes your cousin's unlucky garden gnome, lightning arcs through the sky at speeds so fast you'd need to watch in ultra slow-mo just to catch the details. That bolt of lightning heats the air to around 50 degrees Fahrenheit, about 5 times hotter than the sun's surface. This is less a gentle warming and more a molecular surprise party, where the air suddenly expands faster than you can say, "Not it." That rapid expansion creates a shockwave, the rolling, rumbling sound we know as thunder. Thunder isn't just background noise for sleepy nights. It's a traveling sound wave, sometimes booming right over your head, sometimes fading in the distance like a drum solo from a band several miles away. Because light travels faster than sound, you always see the flash before you hear the boom. That's your cue for a little impromptu math. Count the seconds between lightning and thunder, divide by 5, and you'll know roughly how many miles away the storm island. More importantly, you'll look impressively knowledgeable to anyone else huddling with you in the dark. But why does thunder sometimes crack, sometimes rumble, and sometimes seem to roll on forever? That's the storm playing with distance, terrain, and air conditions, each thunderclap shaped by the landscape and the layers of atmosphere it echoes through. Sharp cracks mean the lightning's close. Long, drawn-out rumbles mean it's skipping across the hills and bouncing off the clouds before reaching your ears. Lightning isn't just a flashy performer, it's a cosmic multitasker. Every year, there are about 1.4 billion lightning strikes on Earth. Without lightning, the world's nitrogen cycle would be out of sync, as each bolt helps convert atmospheric nitrogen into forms plants can use. So every time you see a lightning flash, know that it's fertilizing the ground, even as it scares your dog under the couch. And as for those wild lightning-shaped forked sheet ball, they're all different expressions of the same electric urge to even the score. Ball lightning is the rarest, like the atmosphere's attempt at abstract art. Most of the time, though, you just get the simple, breathtaking fork slicing the night in two. So, next stormy night, as the sky delivers its own drum and bass show, let the rhythm lull you to sleep. The planet's oldest concert is playing just outside your window, a thunderous electric lullaby reminding you that sometimes the best mic drops are the ones that shake the whole sky. You step outside, and suddenly the sky is swirling in neon greens and pinks. No, you haven't been microdosing. It's the aurora, a silent light show put on by charged particles and magnetic fields. Somewhere between a screensaver and a cosmic disco, these lights don't even need a Spotify playlist. Let's drift upward to the places where the sky gets truly weird, closer to the magnetic poles, where solar storms throw the ultimate after-party. You're bundled up, maybe on a frosty hilltop in Alaska or a lonely tundra in Norway. The night is so dark, you can hear the snow crunching under your boots and your breath fogging up the air. Then, without warning, the heavens flicker to life curtains of green, waves of pink and violet, twisting and dancing as if the whole atmosphere suddenly decided to practice its interpretive dance routine. But what is an aurora, really? And why does the sky sometimes seem to lose its mind after dark? The secret lies far, far away. With our Sunday, every so often, the sun has a tantrum and tosses out a huge cloud of charged particles like cosmic confetti. These particles, traveling at millions of miles per hour, eventually smack into Earth's magnetic field, which guides them toward the north and south poles, funneling them into the upper atmosphere. When these solar particles meet the gases in our atmosphere, mainly oxygen and nitrogen, they transfer their energy in a process that's equal parts physics and fairy tale. The gas molecules absorb the energy, get excited, who wouldn't, and then calm down by releasing that energy as light. Depending on which gas gets the party invite, you see different colors. Oxygen glows green or red, while nitrogen goes for blue or purple. The result? The world's most exclusive, invitation-only light show. Standing under the aurora, you're reminded how gigantic and electric the planet really island. Each ripple of color is silent. No fireworks, No crackling, just the eerie hush of the cold night and the gentle swirl of lights overhead. If you've ever wondered what it would feel like to sleep in the middle of a cosmic screensaver, this is it. It's like your phone background went 360 degrees and decided to outdo itself. Ever the multitasker, the aurora isn't just a feast for the eyes, it's also a living record of the sun's moods. Ancient cultures told stories of these lights, spirits dancing, battles in the sky, or giant foxes sweeping their tails across the horizon. Modern scientists know the truth, but honestly, charged particles getting frisky in the magnetosphere just doesn't have the same poetry. If you're hoping to catch the aurora, you'll need a dark, clear sky, a cold night, and a healthy disregard for your sleep schedule. The farther north or south you go, the better your chances. And yes, the southern version, the aurora australis, is just as spectacular for those on the lower half of the planet. Here's a little science to sleep on. The same space weather that causes auroras can also mess with satellites, GPS, and radio signals. That cosmic rave above your head? Sometimes it's a party with a few unintended side effects, like satellite hangovers and GPS hiccups. But for you, on the ground, wrapped in a blanket, the only thing that matters is the silent glow on the horizon. You can almost hear the earth sigh, relaxed, enchanted, just a little bit smug that its magnetic field knows how to put on a show. So tonight, as you close your eyes, imagine those swirling lights painting the sky just for you, the aurora, proof that even the coldest, darkest nights can hold the world's most beautiful surprises. No ticket required, and you're always on the guest list. You're sunbathing, except you're actually 15 miles above the surface, where ozone molecules are intercepting UV rays like an overprotective aunt. Without this thin blue shield, sunburn would happen in milliseconds. Say thank you and apply metaphorical sunscreen. Let's float up together through the moody troposphere and into the rarefied air of the stratosphere. There, tucked between 10 and 30 miles above your head, is a mysterious, nearly invisible layer, ozone. Not quite a gas you'd want bottled and sold at the pharmacy, unless your idea of aromatherapy is crisp and mildly stinging, but an absolute superstar when it comes to protecting your fragile human existence. What exactly is ozone? It's a molecule made of 3 oxygen atoms, O3, which is just unstable enough to be interesting, but just stable enough to be useful. Most of the oxygen you breathe is O2, 2 atoms locked in a cozy partnership. Add a third, and you get a molecule that's sort of like oxygen's wild cousin, who only shows up for the most dramatic family gatherings. But what makes ozone special isn't its chemistry, it's its role as the atmosphere's ultimate bouncer. When sunlight bathes the Earth, it brings along a generous supply of ultraviolet UV rays, some of which are fantastic for making vitamin D, and most of which are fantastic for giving you a sunburn faster than you can say, "Where's the aloe?" Ozone's job is to absorb and block the most dangerous types, UVC, and a big chunk of UVB. Without ozone, your skin wouldn't just turn pink, it would be cooked. Sunbathing would become an extreme sport with a very short season. Now, imagine each ozone molecule like a tiny, invisible shield, popping UV rays on the nose as they dive toward the surface. It's an endless game of cosmic dodgeball, and ozone plays both goalie and referee. And, like any overprotective guardian, it sometimes overdoes it, creating that fresh, sharp smell you notice during thunderstorms or around copy machines. A little ozone at ground level is fine. Too much, and it can irritate your lungs. But up in the stratosphere, it's exactly where you want it. Of course, this superhero layer has its kryptonite. Back in the late 20th century, humans began sending up chlorofluorocarbons, CFCs for short, in the form of old-school aerosol sprays, air conditioners, and refrigerators. These chemicals wandered up into the stratosphere, where sunlight broke them apart and unleashed chlorine atoms, which proceeded to shred ozone molecules like a blender set to obliterate. The result? the infamous ozone hole, especially over Antarctica, where the thin blue line nearly disappeared every spring. The world responded with the Montreal Protocol, an international agreement so effective it deserves its own superhero cape. Gradually, ozone-destroying chemicals were phased out, and the ozone layer has been staging a slow, triumphant comeback, proof that, occasionally, humans can work together to save the planet and their own skin. The ozone layer does more than just block sunburn. By filtering out intense UV, it protects the DNA of every living thing on Earth, from the whales in the sea to the moss in your sidewalk cracks. It shields our crops, our forests, and yes, even the garden gnome who survived the last thunderstorm. So, tonight, as you drift off, maybe imagine yourself sunbathing not on a beach, but in the stratosphere, surrounded by trillions of hard-working ozone molecules, each one sacrificing itself to keep you safe from solar overexposure. Thank the sky's blue bodyguard for every gentle tan and every missed sunburn, ozone. Sometimes it smells weird, sometimes it's a trivia answer, but every single day, it's the reason you get to enjoy the sun and not just survive it. Ever tried falling asleep in July with the fan blasting and the sheets sticking to your legs like saran wrap? Humidity is the silent, sweaty partner in your nightly routine. Tonight, we'll float through dew points, mugginess, and why your hair thinks it's auditioning for an 80s music video. Let's start with the basics. Humidity is simply water vapor. Yes, actual water dissolved invisibly in the air. On a dry day, you barely notice it. But add a little more heat and moisture, and suddenly your home transforms into a tropical greenhouse where the ferns thrive and you, not so much. Humidity is what makes summer nights feel longer, stickier, and just a bit more dramatic than they need to be. But what actually happens when humidity goes up? Here's the science in sleepy, relatable terms. As warm air holds more water vapor, it's like the atmosphere is running a never-ending bath, slowly filling your world with invisible steam. The more humid it gets, the more that steam clings to every surface, including you. Your skin feels clammy, your pillowcase starts developing a personality of its own, and your hair transforms into a tribute to late-night MTV. Ever wonder why your body gets so uncomfortable when humidity spikes? Your sweat is supposed to evaporate and cool you down, but when the air is already saturated with water vapor, there's nowhere for your sweat to go. It just sits there. You're marinating, not chilling. This is why the phrase, "it's not the heat, it's the humidity," has been whispered through history by anyone who's ever tried to sleep on a sticky summer night. Now, let's talk about the dew point, that mysterious number meteorologists love to mention. The dew point is the temperature at which the air becomes fully saturated and can't hold any more water vapor. When the air cools to the dew point, excess moisture condenses, forming dew on your lawn, fog in the air, and the mysterious puddle under your glass of iced tea. If the dew point is high, you can bet it'll feel like you're living in a steamed vegetable bag. If it's low, the air is crisp and dry, your hair stays reasonable, and the world feels manageable again. Humidity doesn't just mess with your comfort, it plays tricks on your senses and your stuff. Your bread goes stale faster, your electronics get grumpy, old books in your basement quietly warp and sigh. Even your pet may start to look at you like, really? You're the one who controls the thermostat, and let's not forget hair. Humidity breaks down the hydrogen bonds in your hair's protein structure, which is a fancy way of saying your sleek style morphs into a retro frizz sculpture. It's not you, it's the air. On the plus side, some plants and frogs are loving every second, but humidity has its charms. It helps rain clouds form, keeps your skin from turning into sandpaper, and makes forests lush and green. Without it, the planet would be nothing but dry deserts and parched lips. Even the most stifling summer night owes its sticky beauty to this invisible, essential ingredient. So as you lie in bed, fans spinning, listening to the distant chirp of crickets and the low hum of air conditioners, remember, you're wrapped in the world's oldest, stickiest, most personal blanket. Humidity is the reason you reach for a cold drink, the reason your plants grow tall, and the quiet reminder that, sometimes, the air just needs a little extra drama. Tonight, let the mugginess melt away as you relax into the softness of your own bed. The world is sticky, sure, but it's also lush, alive, and full of sleepy stories floating in the air, waiting for you to drift away. Every time you see a pink or orange sunset, that's atmospheric particles scattering sunlight, nature's way of flexing on every Instagram filter. The science behind this mood lighting is stranger and more poetic than you'd think, even if your phone camera never gets it quite right. Let's settle in for the ultimate golden hour, where the sky itself turns into a living painting, no filters, no edits, just pure science and a little bit of cosmic luck. Picture yourself on a quiet evening, the air cooling, the world slowing down, and suddenly the sky bursts into color. Soft pinks, deep oranges, fiery reds, and sometimes purples and golds that look too magical to be real. Your phone, of course, tries and fails to capture the moment, leaving you with blurry blobs and a vague sense of betrayal. So what's actually going on up there? It all comes down to something called Rayleigh scattering, which is less about rays named ley and more about sunlight bouncing off the tiniest molecules in the atmosphere. During the day, when the sun is high overhead, sunlight takes the shortest route to your eyes. The shorter blue and violet wavelengths get scattered in all directions by oxygen and nitrogen, which is why the sky looks blue most of the time, your own personal spa ceiling provided free of charge. But when the sun starts to set, it's no longer beaming down at you from straight above. Instead, its light has to pass through a much thicker slice of the atmosphere, like shining a flashlight through a mountain of cotton candy. Along this long path, those shorter blue and violet rays get scattered away completely, leaving behind the longer, more dramatic reds, oranges, and pinks. It's basically the sky's way of saying, let's get moody. Add in a few extra ingredients: dust, pollen, pollution, or even the lingering ash from a distant volcano, and the sky pulls off its boldest color schemes. Sometimes it's a gentle watercolor wash. Other nights, it's a psychedelic light show, making every sunset a limited edition work of art. The best shows often come after storms, when the air is scrubbed clean and the sun's last rays catch every stray particle in the sky. Ever noticed how sunsets feel different? They're not just visual, they're a full-on sensory experience. The world seems to hush, even the birds pause to take it in. There's a warmth that has nothing to do with temperature, a sense that something ordinary just tipped into the extraordinary. It's a trick of light, yes, but also a trick of timing, reminding you to pause, breathe, and let the day's worries melt into the colors overhead. And let's not forget the famous green flash, that elusive split-second emerald spark you sometimes see right as the sun dips below the horizon. It happens when the atmosphere bends and splits sunlight just right, briefly isolating the green wavelength. Blink and you'll miss it, but for those lucky enough to spot it, it's the ultimate mood lighting flex. Of course, the colors aren't just for you. All over the planet, animals and plants use the changing sky as a signal. Time to roost, time to close petals, time to settle in for the night. Even if you're stuck inside, peeking out the window during your late-night doom scroll, the sunset is still there, quietly dazzling anyone who looks up. So, as you drift off tonight, imagine the soft wash of sunset colors above you. Let the pinks and golds fade into deep indigo and gentle violet, your own private aurora, painted by the air itself. Remember, the sky was doing mood lighting long before anyone invented a ring light, and tomorrow, no matter what, there'll be another show just waiting for you to look up. Imagine highways in the sky, only there are no speed limits and traffic jams can cause actual weather. The jet stream is a river of air so fast that if it ran through your commute, you'd be home in time for yesterday's dinner. Let's fasten our imaginary seatbelts and ride up to where the air is thin and wild, the upper levels of the atmosphere, a place where airplanes play and the clouds look like slow-motion sculptures. Up here, somewhere between the troposphere and stratosphere, you'll find the jet streams, narrow bands of air, thousands of miles long, just a few miles thick, and moving faster than the plot of your favorite streaming series. But what exactly are these atmospheric highways, and why do they exist? It all starts with the sun, because, let's face it, most weird weather things do. The sun's energy heats the Earth unevenly, more at the equator, less at the poles, which means the air wants to even things out. As warm air rises at the equator and cold air sinks at the poles, the atmosphere starts churning with the world's longest-lasting game of hot potato. Now, add in the Coriolis effect, the planet's gentle, sneaky spin, and you get wind patterns that swirl and bend instead of running straight north and south. The fastest of these winds gets squeezed into narrow bands at about 30, 0 to 40, 0 feet above sea level. Voila, jet streams. Let's talk speed. The jet stream can blow at over 200 miles per hour. That's so fast that if you could hitch a ride from New York to London, you'd arrive with enough time to regret packing your charger, but still catch a full night's sleep. Pilots love a strong tailwind from the jet stream, shaving hours off their flights, while headwinds have the opposite effect, turning a quick hop into an epic, snack-consuming marathon. But the jet stream is more than just a wind tunnel for airplanes. It's the atmosphere's unofficial weather maker. Like a cosmic paintbrush, it pushes around high and low pressure systems, steers storms, and helps determine whether you'll need an umbrella, a sun hat, or both on the same day. When the jet stream swoops down, it can pull Arctic air deep into the continent, giving you a surprise snow day in April. When it drifts north, it lets tropical air sweep in, turning your backyard barbecue into a steam room. Jet streams don't always flow in neat straight lines. They wiggle and meander, making giant loops called Rossby waves, named after the scientist who first noticed them, and not, sadly, after a famous surfing dog. Sometimes these loops get stuck, which is how you end up with weeks of rain, unending heat waves, or the kind of winter that makes you question all your life choices. Yes, weather traffic jams are real, and sometimes they last longer than your last work meeting. If you could see the jet stream, it might look like a silvery ribbon wrapped around the planet, unraveling, re-knotting, shifting with the seasons. There are actually several jet streams, including the polar jet, which controls much of North America and Europe's weather drama, and the subtropical jet, in charge of mild chaos in the southern sky. So, as you settle under your own blanket tonight, imagine a river of wind racing overhead, reshaping weather, speeding up planes, and occasionally reminding meteorologists who's really in charge. The jet stream is proof that the atmosphere is never still. It's always moving, always changing, like a freeway without an off-ramp. And if you're ever stuck in traffic, just remember, at least you're not a cloud, trying to merge onto the world's fastest, most unpredictable sky highway. Somewhere over the rainbow is a PhD in optics. When sunlight meets raindrop, you get a color show that's equal parts science and happy accident. Tonight, we'll slip behind the curtain and see what it's like to wear the sky's best accessory. Let's start with a question as old as storybooks. Why do rainbows even exist? Why, after a rainstorm, does the sky suddenly decide to coordinate its outfit and go full Technicolor? The answer is a recipe of sunlight, water, and just the right angle, no magic required, though a sprinkle of wonder is definitely encouraged. Picture yourself standing in the gentle aftermath of a summer shower. The air smells like petrichor, everything feels new, and somewhere behind you, the sun finally peeks out. In front of you, droplets of water hang suspended in the air, glistening like tiny crystal beads. Each of these droplets is about to become a miniature prism, ready to split and bounce sunlight in every direction. Here's the behind the scenes. Sunlight, although it looks white to us, is actually made up of many different colors, all traveling together until they hit something that forces them to go their separate ways, like a pop band after one too many world tours. When sunlight enters a raindrop, it slows down and bends, a process called refraction, splitting up into a spectrum of colors. Next, the light reflects off the inside surface of the droplet, like a tiny disco ball. As it exits, it bends again, and the different colors fan out into a wide arc, red on the outside, violet on the inside, with orange, yellow, green, blue, and indigo in between a 7-layer dip, but less messy. You can only see a rainbow when the sun is behind you and rain is in front of you, usually in the early morning or late afternoon when the sun is low in the sky. If you ever wondered why rainbows seem to follow you down the road or vanish the second you try to chase them, it's because a rainbow isn't actually out there in the sky. It's the result of light bouncing straight into your eyes at just the right angle, usually about 42 degrees from the direction opposite the sunday. Try to get closer, and the whole setup shifts with you, always one magical step ahead. Sometimes, if you're really lucky, you might spot a double rainbow. The outer, fainter bow is caused by light that bounces twice inside each raindrop before it escapes. This second arc has its colors reversed, red on the inside, violet on the outside, like the sky can't make up its mind about color order. Occasionally, you'll spot faint supernumerary bands, pastel extras stacked up inside the main bow bonus layers in the 7-layer dip. Rainbows aren't just for dreamers and poets. In science, they've helped teach us about light, color, and the nature of waves. Isaac Newton famously used a prism to show that sunlight could be split into a rainbow of colors, sparking centuries of discoveries about optics and physics. Cultures around the world have woven rainbows into their stories, from ancient myths of bridges to the gods, to promises of peace after storms. There's even a frog in South America whose skin flashes every color of the rainbow when it's startled a walking, hopping weather phenomenon. So tonight, as you drift off, picture yourself slipping on a rainbow wearing the sky's best accessory, each color gently fading into the next. No need to chase the end or hunt for gold. The real treasure is the science and beauty swirling in every raindrop and every sleepy sunlit memory. Rainbows, proof that the sky has a sense of style, and sometimes a sense of humor too. You can't see it, but you can feel it on your face, through your hair, and occasionally slamming the door at 2 a.m. Wind is the atmosphere's favorite way to move things around, including weather, pollen, and your neighbor's recycling bin. Let's step outside for a moment, imaginary slippers on, robe trailing, just in time to feel a gentle breeze tickle your skin or, on some days, a gusty gale threaten your dignity and your hairstyle. Wind is the atmosphere in motion, a restless, invisible force that never learned to sit still. It rushes past mountains, glides over oceans, and loops through city streets, always on its way to somewhere else. But what actually makes the air move? Like most things in life, it's all about balance, and occasionally, the lack of it. Wind is created by differences in air pressure. Warm air rises because it's lighter, cool air sinks because it's heavier, and the planet's never-ending quest for equilibrium sends air racing around the globe. Picture the world as a gigantic, slightly neurotic bakery, with ovens blazing at the equator and freezers humming at the poles. The result? A continuous shuffling of air, trying to even out the temperature from one side to the other. And yet, wind is rarely a straight shot. The Earth's spin, courtesy of the Coriolis effect, twists these flows into spirals and curves, bending trade winds toward the west near the equator, spinning westerlies toward the east in mid-latitudes, and making the poles a playground for wild, chilly breezes. If the planet didn't spin, wind would be boring and direct, but thanks to that cosmic twist, every breeze gets a little extra style. Wind comes in all moods. There's the gentle zephyr, perfect for napping under a tree or fluttering a curtain on a lazy afternoon. There's the blustery gust, slamming windows and sending hats tumbling down the street. And then there's the full-blown storm hurricanes, typhoons, and tornadoes. Winds so powerful they can pick up houses, move oceans, or rearrange your neighborhood landscaping in minutes. Wind does more than just cool you off or send your allergy medication running for cover. It's the planet's original delivery system, scattering seeds, pollens, and spores to places they'd never reach otherwise. Dandelion seeds hitch a ride to new lawns. Monarch butterflies surf gentle currents for thousands of miles. Even the Sahara's finest dust travels across the Atlantic, feeding the Amazon rainforest with nutrients picked up halfway around the world. Wind, it turns out, is a better global traveler than any influencer with a passport. And, of course, wind brings weather with it. If you ever feel a sudden shift in the breeze, pay attention. The atmosphere is sending you a memo. Warm winds signal storms. Cold winds can mean a front is passing, and a calm before the storm is often the wind's way of taking a deep breath. Wind isn't just for drama, it's also for fun. Sailboats, windmills, kites, and those inflatable tube guys waving in front of car dealerships all owe their existence to the wind's generosity. It's free, renewable, and occasionally just a little too enthusiastic about rearranging your backyard furniture. So tonight, as you lie in bed and hear the gentle whoosh outside or the mysterious rattle of a forgotten lawn chair, think of wind as the world's oldest traveling salesman. No bag, no samples, just stories and weather, shared from house to house, coast to coast. It's the universe's way of keeping things moving, stirring, and alive. Close your eyes, let the air settle, and let the wind tell you its latest secret, carried softly through the dark, straight to your dreams. Why does Earth have a cozy, breathable blanket, while Mars looks like it needs a humidifier and a therapist? It's all about gravity, magnetic fields, and a little planetary luck. Imagine holding onto your favorite blanket in a tornado, except the tornado is space itself. Let's start in the comfort of your own bed, wrapped up in the invisible security of Earth's atmosphere. Each breath you take is thanks to a delicate balance of forces that, for over 4 billion years, have kept our air right where we need it. Meanwhile, poor Mars, our rusty red neighbor, sits out there, dry, chilly, and wearing what can only be described as a threadbare scarf of carbon dioxide. What went wrong for the red planet? And how did Earth manage to keep its cozy cover? First up, gravity. Think of gravity as the world's best weighted blanket. The bigger the planet, the harder it can hug its atmosphere and keep those lightweight gas molecules from drifting away. Earth's gravity is just right. Goldilocks would be proud. But Mars, it's only about half as wide as Earth, and its gravity is a fraction of ours. Gases, especially the light ones like hydrogen and helium, can just drift up and leave. Like party guests who suddenly realize there's another, cooler party happening next door in deep space. But gravity isn't the whole story. Enter the magnetic field, Earth's invisible force field, generated by the spinning molten iron core at its center. This magnetic bubble called the magnetosphere deflects the harshest solar winds, those streams of charged particles constantly blowing off the sun like cosmic hairdryers. Without this protection, the solar wind slams directly into the upper atmosphere, knocking gas molecules loose and sending them fleeing into space. Now, Mars once had its own magnetic field and likely a thicker, wetter, more hospitable atmosphere. Ancient Martians, if there ever were any, probably enjoyed a few warm, muggy afternoons. But Mars's core cooled down and stopped spinning, and its magnetic field fizzled out. The solar wind got direct access, peeling away the Martian air little by little until only the faintest, thinnest shell remained. What's left is barely enough to whisper the word weather, much less support life or stop your lips from chapping in record time. Without atmosphere, Mars is exposed, battered by cosmic radiation, extreme temperature swings, and the full, unfiltered glare of the sun. No clouds, no rain, no ocean breezes, and definitely no oxygen. Meanwhile, Earth's atmospheric blanket remains thick and generous, trapping just enough heat to make the planet habitable, allowing water to flow and weather to swirl, and keeping our sunsets Instagrammable. It's not all bad for Mars. Scientists believe it still loses a little atmosphere to space every day, mostly at the poles where solar winds do their best vacuum cleaner impression. The Mars rovers even measure the escape of particles, adding another tick to the "why you should appreciate Earth's air" column. And it's not just Mars. Venus too has its own troubles. A dense, toxic cloud cover and a runaway greenhouse effect. But even Venus can lose gas to space, its molecules slowly drifting away over eons. Space is a very, very patient thief. So, as you settle in tonight, inhaling a deep, easy breath, send a quiet thank you to the forces that keep Earth's air snug and loyal. It's a team effort, gravity's hug, the magnetic field's shield, and billions of years of planetary teamwork. Mars may look great in the sky, but Earth is the real luxury suite, atmosphere included. Breathe easy and rest in the knowledge that the blanket above you isn't going anywhere tonight. Sound needs something to travel through, and the atmosphere is more than happy to oblige. From your own snores to distant thunder, every noise is a pressure wave surfing the invisible ocean above your head. And yes, that includes your neighbor's garage band practice. Let's stretch out and tune in to the background music of everyday life. The distant train whistle, the clack of rain on your window, the impossibly persistent chorus of local dogs. If you've ever wondered why some sounds travel so far, or why your late-night movie needs to be at volume 2 so the whole block doesn't join in, it's all because of how sound rides through the air. Sound is, at its most basic, a vibration, tiny molecules of air bumping into each other like an invisible game of telephone. When you clap your hands, shout for takeout, or accidentally drop a pan at midnight, you set off a chain reaction. Air molecules near the source start vibrating, bumping into their neighbors, which bump into theirs, and so on. This ripple spreads outward in waves, compressions, and rarefactions until, eventually, it reaches someone else's eardrum, or, if you're a dog, several neighborhood blocks away. The atmosphere is the perfect playground for sound waves. It's dense enough for molecules to pass along vibrations quickly, but not so thick that sound gets stuck before it really gets going. The speed of sound in dry air at room temperature is about 343 meters per second, or roughly 767 miles per hour if you prefer to imagine breaking the sound barrier during your morning commute. But sound doesn't always travel at the same speed or with the same punch. Temperature, humidity, and even time of day can all change how far a bark, beep, or bass drop will go. Ever notice how, at night, faraway sounds seem louder or closer? That's not your imagination, it's physics. At night, the air near the ground cools down, while the air above it stays warmer. This temperature difference can bend sound waves back toward the ground, making noises travel farther and seem clearer. It's why the midnight train sounds so haunting, and why your neighbor's off-key karaoke reaches peak performance right when you're trying to fall asleep. Thunder is a great example of sound in action. A lightning bolt superheats the air, causing it to expand rapidly and create a shockwave, a boom that can travel for miles. If you see lightning and then hear thunder several seconds later, you're witnessing sound's journey across the landscape. For every 5 seconds between flash and boom, the storm is about a mile away. Handy for timing, and also for gauging whether you need to bring in the garden gnome. Sound can be absorbed. 2 thick curtains, carpeting, and even a pillow fort will help dampen vibrations, turning your room into a cozy, soundproof bubble. But in open air, sound can bounce, echo, and stretch astonishing distances. That's why yodelers, wolves, and yes, drummers, all make such an impression in open spaces. It's not all inconvenience and lost sleep though. Sound lets us communicate, share music, and listen to the world's best lullabies. The wind, the rain, the soft hum of a sleepy city. Bats use echolocation to see with sound. Dolphins send underwater clicks for miles, and humans have been singing into the air for thousands of years, hoping someone out there is listening. So tonight, as you settle into the hush of your own room, notice the soundscape all around you, the gentle whir of a fan, the distant traffic, maybe even the echo of laughter drifting in from the street. The air is carrying each note, each murmur, every memory, straight through the invisible ocean, right to you. And if the neighbor's band is at it again, well, consider it just another proof that the atmosphere is a master of long-distance delivery. Every so often, the sky throws a temper tantrum mixing pollution, rain, and chemistry in a way that's less spa day and more chemical peel. Acid rain might sound like a metal band, but it's a real-life remix of our atmosphere's delicate balance. Imagine waking up, stretching, and peeking out the window only to see raindrops that could double as a science experiment gone wrong. Don't worry, you're not about to dissolve like a cartoon villain. For most of us, acid rain isn't an everyday horror, but it is a quiet reminder that the sky is more sensitive than it looks. So, what is acid rain really? Let's start with the basics. Regular rain is already slightly acidic, thanks to carbon dioxide in the air mixing with water to form a weak carbonic acid. Your average raindrop has a pH around 5.6, still gentle enough to water your plants and fill your bird bath. Acid rain, though, takes things to a whole new level, with pH sometimes dropping below 4. That's not lemon juice in the eyes territory, but it's enough to make fish, forests, and even old buildings cringe. How does rain get soured? It's all about the chemistry. When we burn coal, oil, and gas, the process releases sulfur dioxide, SO2, and nitrogen oxides, NO, into the air. These invisible gases drift into the atmosphere, meet up with water vapor, and like two bored students in chemistry class, start forming new compounds, sulfuric acid and nitric acid. When the next cloud comes along, it scoops up these acids, and voila, the rain that falls is now tinged with a little extra attitude. The results? In the past, acid rain has turned clear lakes into lifeless bowls, stripped leaves from trees, and pitted marble statues until they look like they spent the afternoon at a haunted spa. In places where acid rain was worst, entire forests faded, and fish went missing from ponds that had been teeming with life. Old stone buildings, already weathered by time, started eroding faster, their intricate details dissolving in the drizzle. But acid rain doesn't just stay where it's made. Winds can carry pollution hundreds of miles, meaning your neighbor's smokestack might be the culprit behind your unhappy maple tree. Like a bad group project, the blame is shared far and wide. There's good news though. Once scientists figured out what was going on, people got to work regulations, cleaner technologies, and a lot of chemistry later. The skies in many places have started to recover. Power plants now use scrubbers to catch pollutants before they can escape, and cars come with catalytic converters to clean up exhaust. The world proved that, sometimes, a little effort can help the sky calm down. Even so, acid rain is a reminder that the atmosphere is a team project. What we put up there can come back down in ways we don't always expect on our cars, our gardens, and sometimes on our own heads. It's a feedback loop that's both humbling and oddly poetic. A cycle of action, reaction, and, occasionally, cosmic correction. So, tonight, as you listen to the gentle patter of rain outside, know that every drop is a little chemistry lesson, evidence of the world's constant balancing act. The sky can be moody, but with a little care, even its worst days can turn back to gentle, nourishing showers. Acid rain, not a band you'd want to see live, but proof that the sky is always in conversation with the world below, sometimes gently, sometimes with a little extra bite. Just above the clouds, solar winds and cosmic rays are throwing a never-ending party. Space weather affects satellites, astronauts, and sometimes even your Wi-Fi. Turns out, our atmosphere is the bouncer at the strangest club in the solar system. Let's float a little higher past the comforting hug of clouds, beyond the layers of ozone and humidity, to the edge of space. Out here, things get weird. Forget gentle breezes and soft rainfall. The weather above our world is wild, unpredictable, and completely invisible to the naked eye. Instead of clouds and sunshine, space weather is made of particles, radiation, and magnetic chaos, all swirling just a few hundred miles above your pillow. First, meet the solar wind. It's not the kind of wind that ruffles your hair, but a constant stream of charged particles, mainly protons and electrons, flung from the sun at speeds up to 1,000,000 miles per hour. The sun, you see, doesn't just shine, it spits, flares, and occasionally burps out enormous clouds of particles in events called coronal mass ejections. When these hit Earth, our magnetic field and atmosphere leap into action, blocking and deflecting the worst of it. Without that protective bubble, those particles would cook our electronics and make sunbathing look like a risky sci-fi experiment. Still, some solar particles slip through the cracks. When they crash into our upper atmosphere, especially near the poles, they spark auroras, those gorgeous light shows we talked about earlier. But that's just the pretty side. These same storms can also wreak havoc on the technology we depend on every day. Astronauts on the International Space Station, or ISS, for those on a nickname basis, sometimes have to take shelter in shielded areas when solar storms get rowdy. Satellites, circling in high orbits, can be zapped or knocked off course, their delicate electronics fried by invisible cosmic tempests. Ever had your GPS suddenly freak out or your satellite TV cut to static right in the middle of the big game? You can thank space weather for that. Powerful storms can mess with radio signals, blackout communications, or even cause surges in power lines down on the ground. In 1989, a giant solar storm famously knocked out electricity in Quebec for hours, proving that space weather doesn't just stay in space. And it's not just the Sunday. The universe sends plenty of surprises our way in the form of cosmic rays, high-energy particles from distant stars and supernovas. Most of these are harmlessly absorbed by the atmosphere, but a few make it down to Earth, occasionally setting off sensors in scientific labs, or if you're really lucky, triggering a blip in your favorite old video game console. All of this wildness is contained thanks to our atmosphere and magnetic field. Think of them as the world's best security staff, quietly managing the entrance to our fragile blue club. Most of the troublemakers are kept outside, and only the gentlest, prettiest effects make it in, like auroras or the slightly charged taste of air after a thunderstorm. So as you lie in bed tonight, surrounded by the safety of your walls and the warmth of your blanket, remember that just above your head is an endless dance of particles and fields, storms and sunshine, energy from the sun and stars playing tag with our little planet. Earth, thanks to its atmospheric bouncer, keeps the cosmic party at a safe distance, so you can get a good night's sleep even if your Wi-Fi occasionally decides to join the dance. 3.0. No, not the kind that Einstein made famous. These gravity waves ripple through the atmosphere whenever air gets nudged, creating cloud patterns that look like someone's making cosmic latte art. If you've ever wondered why clouds form stripes, here's your soothing, late-night answer. Let's picture a quiet morning. You look up and see clouds arranged in perfectly parallel rows, stretching across the sky like an oversized, sleepy barcode. It's so precise you wonder if the universe accidentally left its to-do list up there. But what you're actually seeing are gravity waves, gentle, invisible ripples in the atmosphere, set off whenever air gets disturbed and tries to settle back down. First, let's clarify. These aren't gravitational waves, the space-time rippling kind that earned Einstein a lot of headlines. Atmospheric gravity waves are, in their own humble way, a nightly symphony of balance and motion. They start whenever something like a mountain, a thunderstorm, or a strong weather front shoves a chunk of air upwards. The air, now displaced, is heavier than the surrounding atmosphere at that altitude. Gravity wants to pull it back down, but air, being dramatic, overshoots, rising and sinking in a slow-motion bounce. It's like when you gently bump a bowl of soup and watch ripples glide from edge to edge. In the sky, these oscillations spread horizontally and vertically, carrying energy for miles. As the waves travel, they create bands of rising and sinking air. Where air rises, clouds form. Where it sinks, the sky stays clear. That's why, On a breezy day, you'll spot clouds in evenly spaced lines and nature's own pinstripes, painted by the physics of balance. Mountains are some of the world's best gravity wave machines. When strong winds rush up and over a ridge, they set off ripples downstream, creating those iconic wave clouds, or even dramatic, lens-shaped lenticular clouds that hover like flying saucers. Pilots, especially glider pilots, love these waves. Riding them can lift a glider thousands of feet higher, with barely a sound except the wind on the wings. But gravity waves aren't just for show, they play a big part in how the atmosphere works. They help stir up the air, mix layers, and even transport energy and momentum from the lower to the upper atmosphere. Some waves get strong enough to break, like ocean waves crashing on the shore, causing turbulence, and sometimes making your airplane seat feel less like a spa and more like a carnival ride. Weather satellites spot these patterns from space, revealing wave trains that stretch across continents, sometimes born from thunderstorms, volcanic eruptions, or even hurricanes. In fact, you've probably seen them in satellite images without realizing what they were rippling fingerprints, reminding us that the sky is always in motion, even when it looks calm. Even the aurora, that cosmic disco we marveled at earlier, sometimes dances to the rhythm of atmospheric gravity waves. These ripples can travel all the way up to the edge of space, where the atmosphere is thin and the colors are wild. So tonight, as you settle into bed, imagine those gentle waves moving through the sky, rising, falling, stirring clouds into stripes and swirls. The next time you spot rows of clouds, remember, you're seeing the signature of gravity, air, and balance, painted in slow motion above your head. A volcanic eruption isn't just dramatic for the ground, it gives the atmosphere a full-body cleanse. From ash clouds to sulfur smells, volcanic gases can paint sunsets and cool the planet, making every eruption a chaotic, sky-high chemistry experiment. Let's set the scene. You're relaxing somewhere far from volcanoes, maybe reading a book, or more likely watching another sleep story. Suddenly, halfway across the world, Earth decides to clear its throat. Deep underground, magma bubbles and churns until it finally bursts through the surface, flinging rocks, ash, and gas high into the sky. It's loud, it's messy, and if you were anywhere nearby, you'd be reconsidering your vacation plans. But what happens up in the atmosphere is a show of its own. When a volcano erupts, it doesn't just send lava flowing down its sides, it also pumps out colossal plumes of ash, water vapor, and gases like carbon dioxide and sulfur dioxide. These plumes can shoot straight into the stratosphere, sometimes reaching heights of over 10 miles. It's like Earth has decided to try out a new air freshener, except it's a bit overwhelming. The ash particles scatter sunlight, giving us those famous blood red and orange sunsets that linger for months after a big eruption. Artists and poets have spent centuries marveling at these fiery skies, often not realizing they're witnessing the after effects of a volcanic temper tantrum. In 1883, the eruption of Krakatoa was so powerful that sunsets around the globe turned surreal, inspiring some of the world's most dramatic landscape paintings, and maybe even scaring a few unsuspecting villagers. But it's not just about the visuals. Volcano breath can change the weather too. When sulfur dioxide hits the upper atmosphere, it reacts with water to form tiny droplets of sulfuric acid, which then float around as an invisible mist. This haze reflects some of the sun's energy back into space, leading to cooler temperatures on the ground. In fact, big eruptions have been linked to drops in global temperature, shortened growing seasons, and, in one famous case, the year without a summer. Talk about a planet-wide mood swing. Of course, all this chemistry comes with its own set of side effects. The air around a volcano often smells like rotten eggs, thanks to the sulfur. Not exactly the world's most popular candle scent, but a clear sign that you should probably stay upwind. Meanwhile, the ash cloud can circle the globe, grounding flights, damaging engines, and giving people thousands of miles away a surprise dusting on their cars and windowsills. Volcanic gases also play a role in the long-term balance of Earth's atmosphere. Over millions of years, they've helped shape the mix of gases we rely on, sometimes adding, sometimes subtracting, always keeping things interesting. Too much carbon dioxide, and things start to warm up. Too much ash and sulfur, and the planet cools off. It's a delicate tug of war, with volcanoes occasionally yanking the rope a bit too hard. Despite all the chaos, the atmosphere has a way of bouncing back. Ash settles out, gases are diluted, and the sunsets return to their familiar pastels. Still, every eruption leaves a mark, a reminder that Earth is alive and the air we breathe is constantly shaped by forces both gentle and wild. So tonight, as you drift off, picture a volcano far away, breathing out clouds and colors into the sky. The next time you see an unusually vivid sunset or feel the air just a little crisper, remember, somewhere, the Earth may have just sneezed, and the atmosphere, like any good house, just opened a window to let in something new. As the sun sets, the atmosphere shifts gears. Cool air slides in like a gentle hand smoothing out your sheets. The science of nighttime cooling explains why nights feel soothing unless, of course, you live somewhere that forgot how to chill. Let's wind down together. The day is over. The sun is dipping low, painting the sky with those mellow pinks and blues, and everything starts to relax, including the air itself. The busy molecules, supercharged and frantic from a day of soaking up sunlight, slow down their dance. You can almost hear the atmosphere take a deep, contented sigh. What exactly happens when the sun goes down and the world starts to cool? During the day, the sun's energy pours onto the surface, heating up the ground, the buildings, the trees, and even the streets that make your flip-flops sizzle. All these surfaces absorb heat, storing it up like a battery. But as soon as darkness settles in, that stored energy is released back into the air, a process called radiative cooling. The Earth radiates heat upward, sending out gentle infrared waves into the sky, where most of it escapes into space. It's like cracking a window in your bedroom to let out the heat of a long summer day. As the surface loses heat, the air closest to the ground starts to cool first. If the night is clear and calm, with little wind and no pesky clouds, the heat escapes quickly, and the air can drop several degrees in just a few hours. That's why your cozy summer night can suddenly turn brisk by midnight, making you reach for an extra blanket. And why dew nature's nightcap forms on the grass and your car windshield as water vapor condenses in the chill. Clouds, on the other hand, act like a soft, snuggly comforter. If the sky is overcast, the clouds trap some of the Earth's radiated heat, reflecting it back down and keeping the night warmer like a cozy, atmospheric throw blanket. This is why cloudy nights feel muggy and clear ones feel crisp. In deserts, where there are few clouds and little moisture, the difference is even more dramatic. The sand can go from baking hot to freezing cold, all in the space of a few hours, proving that, sometimes, the atmosphere just loves a good plot twist. Even humidity gets in on the action. On muggy nights, all that water vapor acts as a subtle insulator, slowing the escape of heat and making the air feel sticky well into the wee hours. But in dry air, cooling is fast and efficient, and you're more likely to wake up with chilly toes. Nighttime cooling isn't just about comfort, it's essential for life. Plants need the drop in temperature to rest and recover. Animals, including you, sleep better when it's cool. Farmers have watched the nighttime chill for centuries, knowing that a cold snap can bring frost or, if you're lucky, keep pests in check. And let's not forget the psychological magic. There's something deeply soothing about the way the air changes at dusk, inviting you to slow down, breathe deeper, and let go of the day. Of course, not everywhere gets that gentle tuck-in. Cities, with all their concrete and asphalt, often stay warmer at night, creating urban heat islands that hold on to the day's warmth long after sunset. Meanwhile, tropical nights can forget to cool off at all, leaving you searching for the cold side of the pillow. So tonight, as you feel the air shifting from day to night, know that the atmosphere is tucking you in, wrapping you in coolness, calming your mind, and reminding every living thing that it's time to rest. Sometimes, the most important part of the day is when everything slows down, the heat slips away, and the world settles into sleep right alongside you. About 62 miles up, the atmosphere throws in the towel and space begins. The Kármán line marks this bizarre boundary where air thins to almost nothing. Imagine walking up a staircase and suddenly floating away, with your lungs politely asking, "So, what now?" Let's take the most surreal elevator ride ever. You're rising past rooftops and jet streams, past all the clouds and weather. The air grows thinner with every floor, your ears popping, your breath getting shallower. By the time you reach the so-called edge of space, the molecules are so far apart, you could drive a delivery van through them and never hit a traffic jam. This is the Kármán line, 100 kilometers, or about 62 miles, above sea level, the point where the atmosphere becomes too thin for conventional airplanes to fly, and up suddenly turns into out. What happens at this edge? Down below, the air is thick with life, sound, and weather. But up here, all those comforting sensations fade. The sky, once blue, fades to inky black, even in broad daylight. The sun burns bright and harsh, but there's no longer enough air to scatter its light into soft colors. Your lungs, if they could talk, would probably recommend heading back down immediately. There's not enough oxygen here for even the world's most intense yoga breathing. If you were to step outside at this altitude, preferably with a spacesuit, your body would feel the difference instantly. With barely any air pressing in, your blood would start to boil. Don't worry, it's more of a subtle fizz than a science fiction explosion. Water in your tissues would evaporate. Every sound would vanish, because there's nothing left to carry the vibration to your ears. It's so quiet, it's almost deafening. Why does the atmosphere fade out rather than end in a crisp line? Think of air as an invisible ocean, its pressure dropping exponentially the higher you go. By the time you reach the Kármán line, you're in a place where every breath is a negotiation and every step is a leap of faith. The difference between air and not air is blurry. There's no velvet rope or bouncer, just a gradual ghosting by all those familiar molecules. This edge of space is where space tourism starts, where astronauts earn their wings, and where weather balloons go to retire. Satellites and the International Space Station orbit a little higher, where drag from the faintest wisps of atmosphere is minimal, but never quite zero. Even the most dedicated vacuum isn't perfectly empty. There are always stray atoms and molecules, mostly hydrogen and helium, floating about, refusing to settle down. And then there's gravity, still pulling at you, still insistent. Contrary to cartoons, you don't just float away. Even at the edge of space, you're bound to the Earth, held by invisible strings. But now, with so little air resistance, you can achieve orbit. All you need is to move fast enough sideways, about 17,500 miles per hour, and suddenly, you're in a permanent fall around the planet, weightless and serene, like a perpetual elevator with no buttons left to push. The Kármán line is more than a technical marker. It's a reminder of just how rare and precious breathable air island. Every cloud, every breeze, every sleepy sigh owes its existence to the 62-mile thick shell we call home. So, as you drift off tonight, imagine yourself climbing those invisible stairs, feeling the air thin, the world fall away, until you're weightless at the edge of everything. The atmosphere doesn't end, it just gently lets go, handing you off to the deep silence of space. And suddenly, you're floating, lungs full of wonder, and the universe feels just a little bigger. Somewhere between "that's adorable" and "wait, what?" is ballooning the way tiny spiders and seeds hitch a ride on the breeze, traveling miles without a single frequent flyer point. Tonight, you're lighter than air, drifting on silken threads. Let's picture a scene that's equal parts fairy tale and science experiment. The sun is warm, the grass is sparkling with dew, and on a single blade, a tiny spider stands poised, ready for an adventure. Without so much as a carry-on bag, it rears up, lifts its abdomen, and releases a strand of silk so fine it's almost invisible. The next moment, the spider is airborne, caught by the faintest updraft, floating high above the earth like a dandelion seed at a summer festival. This is ballooning nature's original air travel, available to anyone small and light enough to trust their fate to the wind. Baby spiders, or spiderlings, are the world's most frequent balloonists. Too tiny to walk across continents, and let's face it, way too tired to bother, they instead launch themselves into the atmosphere, hoping the breeze takes them somewhere full of snacks, and not, say, the middle of the ocean. Most of the time, it works out. Sometimes, a group of thousands can take off together, creating a shimmering rain of silk that looks like fairy floss drifting across a meadow. It's not just spiders, though. Seeds have been using the air as a taxi service for millions of years. The feathery parachutes of dandelions, the whirligigs of maple seeds, and the fluffy coats of milkweed all serve the same purpose. Catch the wind, travel far, and maybe, just maybe, find the perfect spot to grow. Even some bacteria, pollen, and tiny insects get in on the act, rising up in dust devils and gentle breezes, exploring new territory whether they meant to or not. The science behind ballooning is both simple and subtle. When the sun heats the ground, warm air rises, creating gentle updrafts. Spiders and seeds take advantage, releasing their threads or parachutes, and letting the physics of lift and drag do the rest. Some spiderlings can ride air currents for hours, reaching altitudes of over 2 miles, and traveling tens or even hundreds of miles from where they started. Talk about moving out of your comfort zone. If you're thinking, that sounds terrifying, you're not alone. Scientists still marvel at how these tiny creatures survive their journeys. They're so light that they barely notice gravity. Instead, they become part of the atmosphere itself, a living, drifting cloud of possibility. In fact, Charles Darwin once watched spiders land on the deck of the HMS Beagle, miles from shore, their silks trailing behind like little banners. Even the father of evolution was impressed. Ballooning isn't just a cute story. It's an essential part of life on Earth. It helps new generations spread out, escape predators, and colonize new habitats. It even creates micro-ecosystems high above the ground, what some scientists call the aeroplankton. Somewhere out there, right now, millions of seeds and spiderlings are traveling through the invisible highways of the air, living proof that even the smallest beings can take the biggest leaps. So tonight, as you drift into sleep, picture yourself shrinking down, lighter than air, floating effortlessly on a thread or a tuft of fluff. The world below looks big and new. The air is gentle, and the only direction is forward. Ballooning. Proof that sometimes, letting go and trusting the breeze is the most natural thing in the world. Ever seen a mirage on a hot road? That's the atmosphere bending light, turning heat into hallucination. These optical tricks happen all the time, making you question if you need new glasses or just more sleep. Let's set the scene. It's a sweltering summer day. You're driving or walking down a sun-baked street, and up ahead you see a pool of water shimmering on the asphalt. You blink, it blurs, it vanishes as you get closer. Is it a glitch in the Matrix? Nope, it's just physics at play. What you're seeing is a mirage, an everyday example of the atmosphere acting like an impish magician, warping the world for anyone who's paying attention. Here's how it works. Light usually travels in straight lines, but it gets sneaky when the temperature changes rapidly from one layer of air to another. On a blazing day, the surface of the road heats the air immediately above it, much faster than the air higher up. Hot air is less dense than cool air, so you end up with a thin, invisible layer of superheated air lying close to the ground, like a surprise bonus level in the atmosphere. When light coming from the blue sky hits this hot layer, it bends, or refracts, upward. To your eyes, this bent light looks like it's coming from the ground, not the sky. Your brain, forever the overachiever, interprets this as a reflection, often a shiny, watery-looking patch. That's why the water seems to move away as you get closer. You're chasing an image that only exists from a distance. Mirages aren't just for roads, either. The same effect can happen in deserts, where parched travelers have been fooled for centuries by shimmering oases that vanish on approach. In polar regions, a kind of reverse mirage called a superior mirage occurs when cold air lies below warmer air. These can make distant ships look like they're floating above the horizon, or create ghostly images of cities and mountains, nature's own special effects. Sometimes, temperature inversions and the right amount of haze can even create fata morgana. Mirages, a stacked, shifting series of distorted images that look like fairy castles, UFOs, or upside-down landscapes. You might spot them at sea, on frozen lakes, or even over city skylines. All you need are the right atmospheric conditions and a willingness to question reality, if only for a moment. But it isn't only light that gets the funhouse treatment. Sound can bend too. On cool nights, sound waves can travel along temperature gradients, allowing noises to seem much closer or farther than they really are. Ever heard a distant train seem right next door, or voices carry far across a lake at dusk? That's the air itself playing with your senses, just as it does with mirages. At the heart of it all is refraction, the simple bending of waves, whether light or sound, as they move through layers of air with different temperatures. It's a quiet reminder that the world is never quite as solid or straightforward as it seems, especially when heat and light start swapping places. So tonight, as you drift off, let yourself imagine walking through a world of shimmering reflections and subtle illusions, a place where reality bends, the ground glimmers, and even the air seems to whisper secrets. The atmosphere, with its invisible glass and shifting layers, is always waiting to surprise you. No special glasses required. From the hottest day ever looking at you, Death Valley, to rain that fell sideways, the atmosphere has some wild stories. If you've ever wanted to fall asleep hearing about raining frogs or snow in the Sahara, this is your dream segment. Let's drift into the wilder corners of the world, where weather forgets its manners and records are broken in ways that sound less like science and more like fever dreams. Imagine lying in bed while the atmosphere flips through its scrapbook, each page crammed with snapshots of weird, wonderful, and sometimes downright impossible events. Let's start with the big one: heat. The highest temperature ever reliably recorded on Earth was in Death Valley, California, where the thermometer hit a sweltering 134.56.7 degrees C in 1913. That's hot enough to bake cookies on your dashboard and melt your will to go outside. Meanwhile, on the other side of the spectrum, the coldest temperature, a staggering 128.6 degrees, 89.2 degrees C, was recorded at the Vostok Station in Antarctica. At that temperature, your breath freezes, your eyelashes snap, and your sense of adventure goes into hibernation. But the atmosphere isn't content with mere hot and cold. It's a master of strange precipitation. Take raining frogs, for example. It sounds like a joke, but there are documented cases, usually when a tornado or strong updraft sweeps up frogs or fish from ponds and then drops them elsewhere, leaving confused amphibians and even more confused humans. It's proof that, sometimes, the sky just doesn't care about your expectations. How about snow in the Sahara? In 1979, and again in 2018, the desert's iconic red dunes briefly turned white with snowfall. While it didn't last long, the sight of camels trudging through drifts was enough to make meteorologists and Instagrammers equally giddy. The atmosphere, it seems, loves a plot twist. Now, let's talk wind. The fastest surface wind speed ever measured by instruments outside of a tornado was 254 miles per hour, 408 kilometers, during Tropical Cyclone Olivia in Australia. 1,996. Imagine trying to hold onto your hat, your house, or possibly your entire backyard barbecue in winds like that. Tornadoes themselves can produce even faster gusts, though the chaos makes it hard to measure exactly how strong they are. Rain, too, has its records. The most rain to fall in 1 minute, over 1.2 inches, 31.2 ml, in Maryland in 1956. The wettest place on Earth, Mawsynram in India, gets more than 11 meters, that's about 37 feet, of rain every year, enough to make umbrellas a permanent part of the local wardrobe. On the flip side, places like the Atacama Desert in Chile can go years without measurable rain. Their weather forecast a study in patience and optimism. And let's not forget hailstones, some bigger than grapefruits, falling with enough force to dent cars and flatten crops. The largest confirmed hailstone fell in South Dakota in 2010, measuring 8 inches across roughly the size of a volleyball. And then there's lightning. The longest lightning bolt ever recorded stretched more than 440 miles across Brazil and Argentina, lighting up the sky from horizon to horizon. So tonight, as you drift off, remember that the atmosphere is full of surprises, sometimes gentle, sometimes wild, but always fascinating. From raining animals to record-breaking storms, Earth's weather has a flair for the dramatic, and the planet's story is richer for it. Atmospheric oddballs. A reminder that even when things seem predictable, the sky is always ready to break its own rules and keep you wondering, what on earth will happen next? So, here we are, back on the soft, stable ground, where the air is just the right amount of invisible, and your coffee doesn't boil away at room temperature. You've floated through a world of auroras and ozone, of cloud kitchens and atmospheric escape plans, of rainbow optics, raining frogs, and air so ancient it probably remembers what your last password was. Maybe you've wondered, half asleep, how it would feel to drift across the jet stream or fall asleep inside a stratospheric layer cake. Maybe you're still marveling at the quiet resilience of oxygen atoms, the secret choreography of wind, or the fact that every breath you take is a collaboration between the present and the very, very distant past. What's certain is this: the atmosphere is wild, ridiculous, and quietly heroic. It keeps the oceans in place, the sky blue, and your skin more or less attached to your body. It absorbs solar storms, recycles ancient dinosaur size, and once in a while throws a lightning tantrum just to remind us who's boss. Scientists and dreamers alike have spent centuries trying to unravel its secrets, sometimes with million-dollar satellites, sometimes with nothing but a jar, a balloon, and some questionable weather forecasts. So tonight, as you drift into sleep, maybe send up a little thanks to this big, complicated, occasionally moody cloud of gases for protecting your lungs, your houseplants, and all your favorite snacks from the cold, hard void of space. Let yourself appreciate the quiet miracles, the cool rush of night air, the familiar comfort of rain on your window, the gentle, unremarkable gift of breathing in and breathing out. Because science might be absurd, mysterious, and occasionally inconvenient, but it's also a reminder that humans are adaptable, resilient, and endlessly curious. We sleep, we dream, and we wake up wanting to know what happens next. Rest well, breathe deep, and remember out there, above your cozy bed, the atmosphere is still humming, swirling, and waiting to tell you another story. Good night, and sleep easy.